Hello, viewers. Welcome back to Alex's Science Podcast, the podcast where we unpack the natural processes of our planet. Today, we will be exploring one of the most dramatic natural interactions on Earth. What happens when molten lava meets ocean water? This phenomenon is more than a spectacular visual display. It is a complex chemical and physical encounter between materials at very different temperatures. Let's break down exactly what takes place in that clash at the shoreline. First, let's establish the basic players in this interaction. Lava emerging from the Earth typically ranges from about 1,000 to 1,200 degrees Celsius. Ocean water, by contrast, averages around 2 to 4 degrees Celsius in many coastal volcanic regions. When such different temps collide, the process is in many different stages. The moment lava touches seawater, heat is transferred with tremendous speed. The outer surface of the lava cools almost instantaneously, forming a thin, glassy crust, which is volcanic glass, similar to basalt, but with a different atomic structure. This process is known as quenching. It prevents the molten interior from immediately losing heat, allowing lava to maintain its internal flow while becoming insulated by its own shell. This quenching is also what leads to the formation of pelolavas. Although the outer crust cools quickly, seawater continues to find cracks and fractures in that partially solidified lava. When cold water infiltrates the still molten interior, it will flash into steam almost instantly. This causes violent and explosive fragmentation. The molten material shatters into small particles, producing what is known as littoral explosions. Thermal fragmentation produces an array of pyroclastic materials, including tiny shards of volcanic glass known as limu opele. These thin, filamented-like glass particles form when bubbles burst at the surface of lava entering the sea. As seawater evaporates, chloride ions combined with hydrogen ions form a volcanic glass, which form clouds called lays, short for lava haze. Scientifically, lays represents a mixture of condensed acidic aerosols and glass fragments created by the interactions between lava and ocean water. Finally, the accumulation of cooled volcanic fragments and solidified lava contribute to coastal land building. As lava deltas form, they grow outward from the shore, but they are unstable structures. Short-term instability gradually gives way to long-term landscape formation as subsequent lava flows consolidate the delta and turn it into stable land. So what makes this interaction scientifically fascinating? It's the combination of extreme physics and rapid chemistry, all occurring in real time at the ocean's edge. It is demonstrating thermodynamics, fluid dynamics, geochemistry, and volcanic converging at the single interface. In summary, lava meeting ocean water triggers instant quenching, forming volcanic glass. Steam-driven fragmentation causes littoral explosions and creates fine glass particles. Chemical reactions generate acidic aerosols and volcanic vapors. And repeated cycles of flow, cooling, and collapse build new coastal lands while shaping the seafloor. That is going to conclude today's episode of Alex's Science Podcast. Please join us for the next time as we explore another process that shapes the planet beneath our feet.